we can of course nest our while loops. Okay, we have seen how we can use ifs inside of while loops. We have seen it quite a lot of times, but now we can also show how to use while loops inside of while loops. So let's combine the loop that iterates until a multiple of 7 is generated with a loop that loops for a fixed number of iterations, in this case 10 iterations, okay? Or in the case of this code, 100 iterations. So outside we have one loop that iterates 100 times, and inside we have that inner loop that iterates until I have generated a multiple of 7, okay? And every time what I do is that I count how many times it costs me to generate the number of tries. In the end, what I'm going to do is to take the average of the loops inside the loops that I use to generate the multiples of 7. Okay, so in this case, I'm generating multiples of 7 100 times, and on average it took me 7.5 tries. Okay, let's do it again now 1000 times, and it takes a little bit longer, and it took me an average 8.097 times. I can do it again and again. Can I do it 10,000 times? Okay, and the average changes a little bit. Okay, every time was 8.3269. Okay, very close. Okay, so with this I could study potentially the properties of the random number generators. Okay, notice here that I'm outside looping a fixed number of iterations. In this case I looped 10,000 times, okay? And inside I'm doing that other loop where I was doing a while that stops only when I have generated a multiple of 7. Okay, and I'm doing one thing inside of the other. I'm nesting one while loop inside of the other one. So also to see the powers of modern computers, I have looped in a moment. Let's do it again. About 80,000 times, 81,000 times, okay? And in the time it takes to wait, okay? 82,000 times. Computers can loop really, really fast, okay? So we have seen while loops with complex conditions. We have seen while loops that iterate a fixed number of times, or that iterate until something happens, and we have nested them. To finish very quickly, for loops. For loops have their own characteristics, that here we are going to see very simple for loops that iterate a fixed number of times using the range function, okay? And the range function will make me iterate for a fixed number of times from 0 to -1 of the limit that I have given here. For example, from 0 to 4, because I iterated until range of 5. Okay, the range function has its own characteristics. I can give it a start point, an end point, and a step. So if I want to iterate from 3 up to 13, jumping from 2 and 2, I can use range 3, 14, 2, and then I get 3, 5, 7, 9, 11, 13, and so on and so forth. I can do it downward by adding initial point that's bigger than the start point and a minus increment, okay? And here you have other examples. If you don't specify anything, you only get the start point becomes 0. What you specified is the end point, and you jump on +1 increments. Okay, so the default is 0 for the start point and +1 for the increments. When you specify 2 parameters, and those become the start and end points, and the one that's not specified is taken to be the step, and that's 1 by default. So that was a very, very quick introduction to for loops, which we will use more later when we work with data structures, because they will help us traverse those data structures very conveniently and very fast and easily. Okay, we have seen while loops, and we have seen a very quick introduction to for loops too.